Okay, so welcome back to the next part of our solving quadratic equations lesson. Let's take a look at this example and solve for x. If you want to put me on pause for a minute there and try and see how you might strategize to try to solve for x, that would be a good idea. But in any case, spoiler alert, I'll tell you about it. If I have an expression that is already in factored form, like these two, and it's equal to some value, I've got 22 here, but even if it was equal to, 2x or, 4x squared or what have you, if it was equal to anything really, what I want to try and do is I really want to combine all my like terms together. And in this example, because this is already in factored form, what I want to do is I want to take it out of factored form so that I can bring this 22 over to this side and combine it with this expression. And then we're going to end up seeing something that looks like this. And it will equal 0 because I will slide that 22 over. And it's going to take on the same form that you saw in the last video, the intro to solving quadratic equations. So let's go ahead and do that. Let's see what that looks like. Okay, if I expand and multiply, oh. Hello. Okay, let's try that again. I'm not sure what happened. Okay, sorry, let's try that again. So we have 3x plus 1 times x minus 6 equals 22. Okay, so let's go ahead and expand and then simplify this expression here. If I use FOIL, I'm going to end up with 3x squared minus 18x plus x minus 6 equals 22. And then I'm going to bring this 22 over to this side, and I'm going to combine like terms. So I'm going to get 3x squared. I can combine these two terms together because they're like terms, so I get minus 17x. And then I have minus 6 take away 22, which gives me minus 28 equals 0. So now that I'm in this form, I can go back to this idea of, okay, if I factor this expression, and I'm able to do this, then I know that if this is equal to 0 or if this is equal to 0, that the whole entire expression will be equal to 0. So let's go ahead and factor this expression. So remember that you are looking for two numbers that multiply together to give you 3 times 28, which is 84. And it's negative. And you're also looking for two numbers that add together to give you negative 17. If I go through my factors of 84, you'll see I have 1 and 84, 2 and 42, 3 and 28, 4 and, what would that be, 21, 6 and, 6 and 14, then we've got, there's no 7, 8 and 9. And so if I look at all these factors, this is why it's good to know your times tables, because this is just a lot faster. I think we have a match right here, the 8 and 9. If they're both negative, then that means that I should have negative 8 and negative 9. And that will give me, that'll give me a sum of negative 17 and a multiplication of, hang on, they can't both be negative because, my mistake. Hang on a second. yes, one has to be negative and one has to be positive. So sorry, it can't be these two. Whoopsie daisers. Can't be those two. That means that it must be, where will I have a difference that'll give me 17? Oh, it's right here. It's at the 4 and 21. So if I have negative 21 and positive 4, that should give me a result of negative 17 for the sum, and then a multiplication of negative 84. So if I go ahead and I factor these guys now in this way, or not that I factor, sorry, I'm going to factor in a sec. I'm going to split up my middle term, that negative 17x, into positive 4x and minus 21x. So our expression 3x squared will now become positive 4x and minus 21x minus 28, and it still equals 0, so I'm going to keep that around. And now I can factor this. I can look at the first two terms and the last two terms. What's common between these two? The coefficients don't have anything in common, but I can definitely factor out that x. So that way I'll be left with 3x plus 4. For this one, I have, it looks like the common factor is 7, and I will have, again, 3x. Now I want these to be the same, so I will say plus 4, and because I have a negative in front of the 28 and in front of the 21x, that means that this should be negative as well. Okay, so now that I have this expression, I can factor out my x minus 7 times 3x plus 4. And I know that this expression is going to equal 0. So either x minus 7 equals 0 or 3x plus 4 equals 0. And so when I go to solve this guy, I'm going to get x equals 7. And when I go to solve this guy, I'm going to get 3x plus 4 equals 0. And I can actually just go ahead and isolate my x variable so that I end up with 3x equals negative 4. I'm going to divide by 3. And in this example, we have x equals negative 4 over 3. So my solution for my original question, or my original equation, which is up here, 3x plus 1 times x minus 6 equals 22. If I substitute now x equals positive 7 and negative 4 over 3, if I go to substitute these values into my original equation, into here, the left-hand side should equal the right-hand side. And, you know, we can even go ahead and verify it. Okay, let's verify. Make sure that our expression, make sure that our solution is correct. So what I can do is I can plug in x equals 7 into my variable and see if it actually equals 22. So let's go ahead and do that. 3 times 7 plus 1 times 7 minus 6. So I'm going to end up getting 21 plus 1, which is 22 over here. And then I'm going to get 7 minus 6, which just equals 1. And so I have 22 times 1, and that, of course, equals 22. So it looks like left-hand side equals the right-hand side for when x equals 7. So that solution is verified. I can do the same thing with negative 4/3. So let's plug in negative 4/3 into our equation. So I have 3x plus 1 times x minus 6. So now when I plug in negative 4/3, 3 times negative 4/3 plus 1. Okay, I'm going to multiply this with negative 4/3 minus 6. Okay, I want to see if that equals 22. When I multiply these two together, it's kind of like I have 3 over 1, so I can cross cancel. So I'm left with negative 4 plus 1, which is negative 3. Okay, and then for this one, I have negative 4/3 minus 6. If I have negative 4/3 minus 6, again, I need a common denominator to do my subtraction. So I can rewrite this as over 3. Oh, why are you stalling? Oh. Why is it doing that? Hang on a second. Sorry, let's try that again. So, sorry, we were looking at x equals negative 4/3. We were trying to verify that. My apologies. I'm going to have to do this again because my screen was just stalling. That's okay. So yeah, so when I go to plug in negative 4/3 for my x value, it's going to look like this. Okay. This one we just calculated. It looks like it's just negative 4 plus 1, which gives me negative 3. Okay, that's on this side. On the right hand side, the negative 4 over 3 minus 6. I just have to make sure that my this is the same denominator. So I'm going to change this to a 3. That means I got to multiply this by 3 as well. So that gives me 18. Okay, so I have negative 4 take away 18. Negative 4 take away 18 is negative 22 over 3. And I'm multiplying these two together. And then again, same idea. This is like negative 3 over 1. And I can cancel out these 3's, cross-canceling, right, when I'm multiplying my fractions. And I have negative 1 then times negative 22, which gives me positive 22. And again, I have left-hand side equals right-hand side. So that means that both of my solutions, x equals 7 and negative 4/3, they're both solutions in this case for this equation.